All right, so part two here, we're just carrying on, but here in part two, we're past the investments. We're talking about like population growth, exponential growth, or decay in half-life. So um, let's get into number three here. Confined area, population of cockroaches. So the population starts at 120, doubles every 5 days. Question is, how long until there are 10,000? Which, as it says, yes, that is creepy. It's just, I mean, honestly, thinking about 10,000 of any insect in a confined space, I don't know how big this space is, but that's got to be, yeah, pretty gross. Anyways, I digress. So we're looking at our equation for doubling, and now in our problem statements, we talked about this in class. We have two equations. I'm going to use that more traditional style equation. So it's looking like A of t what is a little different from the equation above is that we introduce this variable b. So b is designated either it's 1/2 if the problem is an exponential decay where you've got like a half-life going on, or b is equal to 2 in the event that we are doubling every time. T is that unknown time, so like typically it's unknown. So like in this case, how long will it take the population? So we don't know. T is going to be our unknown. P is the rate at which it's doing its doubling or halving. So it's saying it's doubling every 5 days. So P in this case is going to be a 5. So if we plug all that information in, we actually know our ending 10,000. Really doesn't like short lines. For some reason, it just makes them disappear. We start with 120. So B, in this case, our population is doubling. So that is going to be a 2. T is the unknown. P we said was 5. It's doubling every 5 days. So here we go. We've got our T's up in the exponent. Let's do some simplification. So 10,000 divided by 120. You know what? I'm just going to leave things as is. So really doesn't like short lines. We divide by both sides. 120, we get this. What we're going to do now is we want to take and get the exponent out of there. So we're going to take logarithm of both sides. Just like we divide by 120 both sides, we're taking the logarithm of both sides. So that looks like this, log base 10. What? It doesn't want me to do it anyway. So I'm just going to leave that. So we log the left side. Now we know that the rule of exponents on logarithms says if I take the log of something with an exponent, I can just say, there's a 5 there. We get to bring it out front. And then we can take the log of 10,000 over 120. We can divide both sides by log of 2. And we get 2 over 5 is equal to log of this fraction 10,000 over 120 divided by log of 2. All we do is take and get a decimal answer reduction for that. Take that number times 5, and we see T equals 31.92. So in the spirit of reality, given the information, how long will it take population? It says 10,000. So after 31.92 days, we have that. But again, the spirit of reality, and nobody would measure a fraction of a day like that. So I would say the answer is it'll take 32 days. Because if you say 31, you still have a fewer than 10,000. After 32 whole days, you have a little more. So go on the safe side. Now, let's say the cockroaches did grow. Number 4, we've got 10,000, which yes, is gross. Exterminator comes in, sprays, cockroach's half-life is 3 days. So the population is cut in half every 3 days. How long will it take to have less than 5 cockroaches left? With this one, we're using that half-life formula. It's the same thing, but instead of B equaling 2, we're going to say B equals 1/2. So A of T equals the initial amount times B, which is our half, and then T it is asking how long will it take. So T is our unknown, and the half-life is occurring every 3 days. So P is 3. I am going to go ahead and redraw this to save time and space. We want to know when that is less than 5. So we're just going to set it to 5. So if we divide both sides by 10,000, we get 5 equals, what happened? Here we go. T over 3. We're gonna take logarithm both sides. So actually, no, what we can do, maybe I'll try it a little different here. I'm gonna rewrite this as a logarithm. So if I say log base of 1/2 of this number equals T over 3. Okay, so 1/2 raised to the T over 3 equals this really small number. That's just the logarithm form of the previous line. And now how are we going to solve that? Well, we know that the change of base formula says that if we take common log of the number up here divided by the common log down here, that equals T over 3. So if I write that out, log half which that actually equals 10.966 days. That is equal to the right side, T over 3. So you take 10.966 times 3, T equals 32.9. days, or again, in the spirit of reality and rounding, nobody will say, well, in 32.9 days, you will have achieved less than 5. So the question is, do you round up or do you round down? So after 32 days, you would still have more than 5 cockroaches because you're halving your population every time. So we would, in this case, again, have to round up. So, so 33 or more days. And there you have it. I'll do questions 5 and beyond after this. I'm stopping part 2 here, but again, we've got questions 3 and 4, that kind of half-life and doubling taken care of.